Our universe hides many mysteries, and among the biggest are black holes. Black holes are some of the most powerful and mysterious objects in the known universe, and no light can escape these giant entities. In this video, we are about to explore the most massive black hole ever discovered. These enormous space giants are some of the most enigmatic bodies prowling the universe. In fact, our understanding of black holes is so limited that what happens beyond the event horizon of a black hole is completely unknown to us, and is a hotly debated topic among astronomers and physicists. Our modern understanding of physics breaks down at the event horizon, but regardless of what we can understand about the black hole within the event horizon, a black hole exhibits very real effects within our known universe, especially through its gravity. Using a black hole's gravity, we are able to measure and discover the actual mass of the black hole itself. And it is at this point that we discover that there are many classes of black holes, and that the most powerful black holes are often billions of times more massive than our own sun, and that their gravity has influence over galaxy-sized regions of space. These stellar bodies are aptly categorized as supermassive black hole. For a black hole to be classified as a supermassive black hole, its mass must exceed 100,000 suns, but this is essentially an arbitrary lower limit set on its size. We have discovered black holes that are several million solar masses, and a few primordial black holes from the early universe that have devoured enough material to exhibit gravitational forces consistent with billions of solar masses. One of the smaller supermassive black holes exists not too far from us. In fact, it is at the center of our very own Milky Way galaxy. At this center, there rests a supermassive black hole that we call Sagittarius A. Due to the activity of the gas surrounding our central black hole, we have known about its existence from about 1933, when Carl Yansky identified a radio signal coming from the central Sagittarius region of our galaxy. But there are so many stars and clouds of dust between our solar system, which rides along the edge of our galaxy's spiral arms and the central region of our galaxy, that conclusive evidence about Sagittarius A being a black hole only came as recently as 2018, when researchers using the Very Large Telescope (VLT) observed clouds of gas in the central part of our galaxy moving at approximately 30% of the speed of light. This is only really possible when there's a strong gravitational influence in that region of space, and it had to come from a black hole. This black hole has existed long enough that it had a significant impact in the shape and evolution of the Milky Way galaxy itself, and continues to be the dominant gravitational force in the central region. The event horizon of this black hole is a staggering 60 million kilometers across, about 40% of the distance between the Sun and the Earth, but packing the mass equivalent of 4 million suns, all crunched up in its central singularity. Sagittarius A has such a strong gravity that stars orbiting this black hole move at very close to the speed of light itself. For instance, S2, one of the stars that orbits this central black hole, orbits at a velocity of 2.55% the speed of light. That's a staggering 7,650 kilometers per second, and gets as close as 4 times the distance that Neptune is from the Sun from the central black hole. This black hole at our galactic core has a strong impact on its surrounding, and I'm very glad our solar system is safely in the fringes far away from this devouring stellar beast. But our neighborhood supermassive black hole is nowhere near the size of the largest supermassive black hole we have seen to date. Whereas Sagittarius A has a mass of 4 million suns, this black hole has an estimated mass about 15,000 times higher. At 66 billion solar masses, Ton 618 is the most massive black hole scientists have found to date, and its size and age almost defies understanding. At a distance of about 18.2 billion light years, the light from Ton 618 took over 10.8 billion years to reach us. This black hole has formed in the early universe, where there was significantly more matter density and thus far more material for this black hole to devour. Ton 618 is known as a quasar, which is an extremely active and bright galactic nucleus, the light emission from which is so bright it makes it almost impossible to see the light emitted from anything outside of the galactic center. TON 618 is a black hole at the center of an ancient galaxy, feeding off the extremely hot gas and matter in the accretion disk surrounding the black hole. This accretion disk is heated to such high energies that it emits light at an intensity 140 trillion times higher than the sun, with an output of 4 times 10 to the power of 40 watts. This makes TON 618 one of the brightest objects in the known universe. The mass of TON 618 is so high that even if you took every planet and star in the Milky Way galaxy, you would still be about 2 billion solar masses short of the 66 billion solar mass of TON 618. It is so large and massive, with a gravity so strong, that its Schwarzschild radius, the radius of its event horizon, is 1300 astronomical units. That means that from one side of the black hole's event horizon to the other, if you could go through the black hole, would span 2600 times the distance from the Earth to the Sun, or 40 times further than Neptune is from the Sun. TON 618 is a part of what is known as a Lyman alpha blob, which is typically seen as the largest classes of nebula. This means that TON 618 and its host galaxy is surrounded by a cacophony of gas and dust, spanning at least 320,000 light years across, almost 3 times the diameter of the Milky Way galaxy. This ancient nebula has had a combined mass of about 100 billion solar masses, evenly split between its central region, where hot matter and gas is being flung out from the galactic core by TON 618, and its surrounding cold gas in the intergalactic medium. These nebula are the precursors to modern galaxies and give us a look into the early formation of galaxies in the early universe. TON 618 as a supermassive black hole behaves differently than smaller black holes. For instance, it is likely that if we were to stand near the edge of the event horizon, we would not feel any extreme tidal forces like we would in smaller black holes. In fact, it may even be comfortable if we don't consider the radiation exposure from the extremely energetic accretion disk surrounding the black hole. That is to say, spaghettification will not occur. We will not be stretched to our limits, atom by atom, because the gravitational gradient will be low. The other property of note is that the density of the black hole is very similar or even lower than that of water. Counterintuitively, the more massive black holes are, the more friendly they are to be around, at least in stellar terms. TON 618 is only the most massive black hole we have found so far, and it has sparked discussion of delineating another category of black holes, the ultramassive black hole, UMBH, which will include black holes with masses above 10 billion suns. It is still early days of research into the upper echelons of massive black holes and the actual limit of their size. TON 618 is only the largest primordial black hole we have found so far, and its scale almost defies imagination. But scientists think there may be even larger black holes awaiting to be discovered in the vastness of space, and that we have only scratched the surface of what is possible in this great big universe. Explore it all with us as it happens in the Ideaverse. Like and subscribe for future videos like this one, and thank you very much for watching.